Alright, Assalamualaikum, selamat pagi. Okay, this will be the last chapter for SPS260. So next week onward, we are going to have a discussion on the usage of Kinovia or some other tools which we always or which we use almost in biomechanics. Okay, so this will be the last chapter, and this is actually the continuation of what we have learned last week, which is regarding kinematics or pattern. And this week we are going to talk about kinetics or the cause of action. Okay, macam mana pergerakan tu terjadi and whatsoever is being derived from kinetics ataupun the action of force. Okay, and when we see kinetics here, this term is actually representing movement. Okay, bila kita nampak kinetic, maksudnya pergerakan, motion. Kinetic watch, watch that being activated by motion. When we see kinetics, it talks about motion. So today we are going to discuss a bit about linear and angular kinetics. What happened kinetically, which resulting movement. Okay, so basic concept that related to kinetic, we have several. We have inertia. In other words, inertia ni kita boleh je namakan dia sebagai mass. Okay, inertia is actually part of mass. So we have inertia, we have mass, we have weight, we have pressure, tekanan, we have volume, isi padu, density, ketepatan. We have specific weight to measuring pressure later on. We have torque, which is force in term of angular, okay, which is force which produce rotation. And finally, we have impulse or force that being inflicted to an object, to impulse. Jadi dekat impulse ni kita akan bincangkan impulse momentum theorem lah nanti. Okay, so all of this will give you a useful foundation or basis information to understand the effect of force. Jadi force ni yang menyebabkan adanya inertia. Force ini yang menyebabkan mass and weight. Force ini menyebabkan pressure. Force ini menyebabkan volume density. Okay, all of this being derived from force itself. Okay, so we go to the first one. When we talk about inertia, this one, we have a direct relation with mechanical basis of human motion, which is Newton's first law of inertia. Okay, so inertia means a resistance to action or to change, and the mechanical definition is a resistance to acceleration. Okay, so based on Newton's first law, it said that an object, satu benda, if we don't inflict force to that object, it won't cause the object to move. Ataupun if the object is in motion, it will keep on moving with the same velocity. Okay, so Newton's first law or law that talk about inertia. Simple je. Kita ada benda, if we don't inflict force, we don't kick the ball. Okay, when we kick the ball, we give force. This one is the leg lah. So when we give force to the ball, this is what we call the contact between the leg and the ball, which will transfer impulse to the ball, and the ball is going to move. So based on Newton's law of inertia, it said that if the ball does not move, kosong meter per second, it will remain unmovable unless there are force acted upon the system. So if there are no force acted upon the system, inertia said that if the object does not move, if it won't move. If the object is in motion, if we neglect resistance, this ball is going to keep moving with the same velocity unless there are force acted upon the system. Tapi kalau tak ada force, kalau dia bergerak, dia akan bergerak pada kelajuan yang sama. If the object does not move, it will remain unmovable. This first situation is known as static equilibrium. And the second case is known as dynamic equilibrium. Okay, a movable object will remain movable, unmovable object will remain unmovable unless there are force acted upon the system. So if we inflict force to the system, we are going to introduce one properties, just one, for both situation, just one. If you kick the ball, we are going to give impulse to the ball. It will cause change. And this change actually being caused by acceleration. Okay. Kita ada satu bola. Bola ini tidak bergerak. Okay. This is the first condition. We kick the ball. It caused the ball to move. So the second condition, setelah bola tu bergerak pada 5 meter sesaat. So when you see change of velocity, means that there are the presence of acceleration. How to prove that? It's by equation. Let's say this change happened in 1 second. So we have 5 minus 0 divided by 1. The change is 5 meter per second. The acceleration. And that is the reason that make changes towards towards inertia, acceleration. Kalau kes kedua, bola dah bergerak. Okay, 2 meter sesaat, and we inflict force from different direction. It caused the ball to slow down 1 meter per second. So this one is the first situation. This one is the second situation. There are change in velocity. So let's see. A equals to V2 minus V1 over T. Let's say the time taken is 1 second. Similar with the first situation. So we have 1 minus 2 over 1. We have negative 1. Okay, negative 1 meter per second square. So if you have a value for your acceleration, means there are case of disruption. Okay, there are change in inertia. Jadi konsep pertama, konsep inertia. Inertia is the first concept of force. Force being inflicted to an object, which cause changes to the object, and that changes is caused by acceleration. Itu adalah yang pertama. Okay, this one. Resistance to change, resistance to acceleration. So if the object resists to acceleration, means it is still in the state of inertia. Kita sepak dia tak bergerak. Contohlah kita ada satu kotak 100 kg, kita pun sepak dia sikit, tak bergerak. So that kotak is still in inertia. Why? Because the force being inflicted does not cause any acceleration. If the force is enough and cause acceleration, and then inertia will be disrupted. Okay, so nama lain inertia ni, kita boleh panggil dia juga sebagai equilibrium. Okay, resistance to action or to change. The properties of a body or object that resists change in the body motion in any direction. Tendency of a body to maintain its current state of motion, whether motionless or moving with a constant velocity. Kalau benda tak bergerak, tak akan bergerak. Kalau benda yang bergerak, akan bergerak dengan kelajuan yang sama or malar or constant, unless there are force being acted upon the system. That is the concept of inertia. Okay, contoh kalau dalam kes seharian, okay, kita duduk dalam kereta, and then the driver start to driving, we are going to feel that you are going to being pushed towards the chair, being slumped on the chair. Tapi towards the later part of the driving, kamu dah jadi relax because you are in inertia state condition anymore, because there are no more acceleration. So if there are no concept of inertia, if we just leave our bag, our handphone, our water bottle, anything on the floor, it will move on its own. Tu kalau tak ada konsep inertia. Okay, in other words, we can say that without inertia, things can move on its own. Okay, with inertia, it talks about force. Means we need force to change the condition. To inertia. Alright. So that is the first one. Okay. The second one and the third one, mass and weight ni. Dia tak weight kat sini. Tu weight. Okay. Kita terangkan, kita tengok dua-dua ni sekaligus. When we talk about mass, mass simply means substance or matter. Jirim. Okay, jirim. A human being is made of muscles, bone, fat, tissues, and fluid. All is the measure of the body resistance to having its state of motion change. So mass is common to all material things, whether solid, liquid, or gases. Okay. Bila kita cerita mass, cerita dua-dua sekali. We have mass, we have weight. Okay. First, how to differentiate. When you see mass, usually the unit will be in kilogram. Mass. Berapa jisim dia, berapa berat dia. When we see weight, most of the time, the unit will be in kgms. Okay. Kg, sekejap weight, kg, and acceleration, ms. Or, it is in the unit of Newton. Selalunya antara dua ni. Kadang-kadang kita nampak kgms, ni mass, no. When you see kg and ms, meaning it is a derivation of kg time dengan ms. Ms ni unit apa? Acceleration. So, to get weight, what we need to do is actually to have mass times with acceleration. So, the final unit will be kgms, or it will be in terms of Newton. Jadi, when you see weight and the unit is in Newton, means that weight is also a form of force. Okay. And this form of force is needed in order to move mass. Why we need to move mass? Because of concept of inertia. If we don't apply force, and then the mass is not going to move. If we apply uneven or unequal amount of force, the mass is not going to move. So if we need, or we try to propose a motion, we need to apply force to mass in order to make it moving. First kita kena differentiate. Kalau nampak kg, it is mass. Kalau nampak kgms, it is weight. Ataupun when you see Newton. Dengan mass, kg. Newton, mass kali acceleration. Newton. Itu ialah weight. Okay. To differentiate that first. Right. So for mass, tak ada. Saya bagi tahu ni nilai je. Kita tengok yang kedua. Description of force. Okay. Force can be called as either push or pull or blow. Pukul. Okay. So tarik boleh, tolak boleh, pukul boleh. In other words, force change the nature. Either you push, you pull, or you blow. It will change. Let's say the thing is here. Okay. The thing is here, A, and you push. Dia berubah tempat. So this pushing action is force. If dia dekat A, and then you pull, tarik dia ke bawah, berubah tempat. So this pulling action is known as force. Kalau dia dekat A and then you kick, sepak dia. Okay, we inflicted impulse, making the A change place to D. So this inflicting impulse is known as force. So anything that change the nature of a motion is known as force, whether it is a push, a pull, or a blow. A force is something that cause or tend to cause a change in motion or shape. Tengah lari-lari, tiba-tiba kamu yang melanggar dinding, cause change toward your face. Means you inflicted force to the dinding. Tapi dia kata sini tadi push, pull, or blow. Kita langgar dinding tu case macam mana? Okay. So, remember again Newton's third law, where it say that for every action, there will be a reaction, but from different direction. Ini Newton law yang ketiga. So if you're running and you smack your face on the wall, katalah 100 Newton, means that at the same instant of that contact, the wall is going to return back to you 100 Newton. The difference is just towards the direction of action. You inflict the wall for 100 Newton. The wall will return back 100 Newton to you, causing your face to crush. Macam mana kita nak wall ni bagi 1000 Newton? Senang. Kamu bagilah 1000 Newton dekat wall tu. Instead of running, maybe you can slam on the wall while riding a bike. So you're going to be having a lot more side effect based on Newton third law, action reaction. When we give something to something or somebody, it will return back the favor with the same equal amount but in different direction. Kita tumbuk orang, tapi orang tu tak tumbuk kita balik. Okay, we have people punch the face of another people. Katalah 10 Newton. Okay, tapi orang ni tak return balik. This person, the B person, does not return the punch. So how Newton third law works? Okay, when you apply 10 Newton from your fist to the face, at the instant of contact, you're going to feel something at your fist. And that feeling is equal in terms of amount being inflicted to you but in different direction. Contact tu sendiri will return back the force but in different direction. Itu konsep force. Okay, a push, a pull, a blow, anything that change, okay, anything that cause or tend to cause a change in motion or shape of an object where it has contact. Itu adalah konsep force. Okay, so in mechanics, okay, in physics, force can also be described as the interrelation between mass and acceleration. Okay, dia boleh kita boleh kira dia. This is what we call a secondary method by using calculation. Okay, so from force equals to ma. Okay, now if we make it in a simple form, we can write it out as mass, acceleration is v2 minus v1 over t2 minus t1. And then we are going to switch place for the bottom part of the equation to the left hand side. So we are going to have f t2 minus t1 equals to m v2 minus v1. Okay, in mathematics, when you see something like this, the same thing, this is time, and it has two different time period, time final minus time initial. We can change this into final initial ni kan, final minus initial, we can change that into the change of. Same here, final initial, so it is equal as the change of. The change of what? Kalau sini t, so t lah. Kalau sini v, so v lah. Jadi kamu dapat ft equals to mv. Alright, and then in mechanics we have impulse, where we can write it as I besar equals to ft. F is force, T is time. So impulse talks about how much force being inflicted towards an object in a period of time. Contoh, kita main hoki. So kita ketuk bola hoki. Okay. When we ketuk bola hoki, there will be 3 distinct time frame. 1, kita ada swing. 2, kita ada contact. 3, kita akan ada separation. Okay, bola datang, kaki Okayu datang, ketuk bola, and dia akan hayun bola tu ke depan. So at the instant of that ketuk, this is known as contact. Okay, and then you are going to bring the ball forward, and after a certain period of time, there will be a separation where the ball does not have any more contact with the stick. So that contact towards separation is the time that we have interest of. Selalunya tak lama. 1 second, half a second, 0.8 second, 1.1 second or whatsoever. So that contact, that time between contact and separation with the amount of force being generated ni, force being generated by the kayu ni, these two things is impulse. I equals to Ft ni, first part of this equation. And then when we inflict force to an object, inertia tadi, it cause the object to accelerate. It cause the object to move. If the object does not move, it will move. If the object in motion, it will increase the movement. So that amount of movement, berapa banyak dia bergerak, we can name it as momentum. So momentum is how much movement occurs. Okay. M besar equals to M kecil, V kecil, M kecil. So the little caps, the small caps, M is mass of the object, and the V is the velocity of the object. So M besar, MV, the second part of this equation. Ft equals to MV. In other words, okay, when we have Ft equals to MV, meaning that Ft is impulse, M is momentum. So these two things is actually equal in numbers. Contohnya, okay, contohnya. Katalah kita ambil golf. Okay, we take an example of a golfer. So now in the process of swing and then contact. Okay, ni swing, contact, travel. Alright, let's say in order for this player to swing, he generated, let's say 80 Newton of force at the hand column. Okay, 80 Newton of force at the hand column. And then the swing, okay, the swing itself, okay, swing ni, katalah this action of swing takes 1.2 second. So how much impulse will be inflicted to the ball after the club contact? Kita akan kira I equals to Ft, where F is 80, T is 1.2. So we are having 1.2, 1.2, we have 96 Newton per second. So these are the amount of impulse inflicted to this object. Ini benda ni kamu kena tunjuk dekat kamu punya presentation. Kalau kamu tengok bahagian 2, bahagian 3, we have kinetic, we have impulse momentum theorem. Okay, so let's see, the amount of impulse is 96 Newton per second. So now next question is, by having this 96 Newton per second, how fast the ball is going to travel? Let's say the mass of the ball is 150 gram. Okay, mass equals to 150 gram or 0.15 kg. Okay, berapa laju bola tu? So we can further that one by using the second part of the equation, the momentum, because everything that been inflicted with a force, with an impulse, will move. Meaning that you have impulse, you have momentum, and the amount is equal for both. Jadi kita ada momentum equals to mv. So how much is the ball momentum? Equal as the amount of impulse, 96 Newton per second equals to mass of the ball, 0.15 v. So v will be 96 over 0.15. Berapa? Equals to 640 meter per second. Ini kita punya assumption lah, 640 meter sesaat. Setengah kilometer satu saat bola ni boleh travel kalau kita apply 80 Newton of force at the contact. Ni dia. Okay. Ini salah satu contoh how we use impulse and momentum. And what is impulse? What is momentum? So impulse is the amount of force inflicted. Momentum is the amount of movement after impulse being inflicted. Okay, katalah kita ada seorang lagi novice player and this player does not swing to the full, he swing halfway. Okay, and the time taken between start action to the end is 1 second. Tadi 1.2, sekarang 1 saat. With the same amount of force being delivered, how fast the ball is going to travel. Okay, jom kita tengok. Saya padam sikit sini, kita pindahkan equation ni ke sebelah. Okay, kita ada 640. So here the momentum is 640 meter per second. Okay, here kita kira dia punya impulse dulu. So the impulse is force times time. So 80 times 1, we have 80 Newton per second. Tadi kita ada 96. So the change is only towards, okay, the difference for time is only 0.2 second. The difference of impulse is 16 Newton per second. Ini perbezaan. Beza masa 0.2 sahaja. Now let's see the difference in term of momentum. Okay, momentum 80 equals to mass 0.15 V. So the V is 80 over 0.15. 80 bahagi 0.15. We have 533. 533.33 meter per second. So if we have 640 minus 533.33, the difference in term of momentum is 106.7 meter per second. Ni how we want to prove momentum and what we call it impulse. Okay, a difference of 0.2 resulting a difference of 100 meter per second ataupun 0.1 kilometer. Perbezaan dia tu sangat ketara. Although in action it just a mere 0.2 second. So what does it means? It means here that by having full ROM, although it takes only a mere 0.2 second compared to not so full ROM, the outcome is significantly different. Okay, the outcome is totally different. Although the input is just a slight difference, but towards the end, it's too much. Ini cara untuk kamu explain lah why we need to have full ROM based on kinetics. Okay, this is based on kinetics. So the thing that I show you here, the derivation of F equals to MA up until you have Ft equals to mv, this is what we call as impulse momentum theorem. Okay, a theory which relate impulse and momentum. So at the end of the day, we have impulse is equals to momentum. Means if we give more impulse, we get more momentum and vice versa. Okay, contoh penggunaan lain. Katalah, we have a car. Okay, we have two car. Ini dalam engineering lah. Dengan kereta yang kedua, sama je rupa dia, but it use a different materials. Okay, kereta A guna besi, kereta B guna aluminium. Ni orang panggil tin Milo ni, macam kereta-kereta sekarang. Okay, both of this car has the same amount of velocity. Velocity moving at 60 km per hour. Yang ini pun at 60 km per hour. Okay, alright. So let's say kereta A ni smash with the wall, and after it smash, okay, kereta tu berlanggar, lepas tu sebelum dia return back, okay, bila dia langgar ke depan, there will be a period of time dia akan crumple, and then it will bounce. Jadi at the point of contact to the instant of bounce, these are the time. Okay, katalah masa yang diambil untuk berlanggar lepas tu bounce is 3 second. Okay, masa untuk diambil untuk berlanggar and bounce is 3 second. So my question is, how much force occurs within this system? Okay, katalah kereta ni bergerak pada kelajuan 60 km sejam, and the mass of this car is 1000 kg. Okay, 1000 kg. First kali kita kena tukar V ni jadi meter per second. Okay, so kalau 60 km sejam, berapa meter per second dia? Tu kita kena tahu yang tu. Okay, berapa meter per second dia? 60 km per jam. 60 km sama dengan berapa meter? 6 km 6000. 60 km 60,000. Okay, 1 jam ada berapa minit? So 1 jam ada 60 minit. 60 minit, setiap minit ada 60 saat. So 1 jam ada berapa saat? Okay, so kita ada berapa ni? 1 jam 60 kali 60, 3600. 60 kali 60, we have 3600, and then 60,000 divided by 3600, we have 16.7. Okay, so velocity dia ialah 16.7 meter per second. Okay, now we try to find out force. So force equals to apa dia? Kita ada Ft equals to I. In order to find I, we need to find M. So berapa momentum dia dulu? We have mv equals to 1000 times with 16.7. 1, 2, 3. 1670 Newton per second. Okay. So now we have the I. Ft. So I dia ialah 16,700. F and T dia ialah 3. So F equals to 16,700 divided by 3. We have 5567 sama dengan 5567 Newton. These are the amount of force inflicted to the car. Okay, kereta yang kedua. Since it is aluminium, so the crumpling action will take longer. Tadi 3 saat. Yang ini mungkin dia punya crumpling action sebelum bounce back is around 6 second. Double up the iron rod. Okay, so double up the iron rod. So the question is, if this car is similar in terms of mass, so how much force being inflicted towards the passenger of the car? Benda yang sama. So we find out mass momentum dia dulu. Equals to 1000 times 16.7. So kita ada 16,700. Okay, and then the impulse is Ft. So Ft is 3. 16,700 equals to F3. F6. New time is 6 seconds. So the F now is 16,700 over 6. (2783) equals to 2783 Newton. Okay, let's say human being can withstand 3000 Newton of force before cripple. Orang kat dalam ni yang naik kereta ni, maximum amount of force is 3000 Newton. So, if orang dekat A inflicted by 5567 means that he will cripple. But orang dekat B being inflicted by only 2783 maksudnya dia akan cedera. But not parah. This how people play around with impulse and momentum. Beza dia apa? Sorry. Beza dia only this one. You have similar velocity, you have similar mass. So, the difference of just 3 seconds in a car crash, 3 seconds, in a real world, when we see things, 3 seconds is not much. But in car crash system, 3 seconds already give you difference how much. Ini kalau kita ambil 6,000, this one is 3,000. It give you a difference of 3,000 Newton in term of force being inflicted towards orang dekat dalam tu. Ni cara untuk kita guna force and impulse and momentum. Tadi we use impulse and momentum in order to find out the velocity outcome, and this is an example of how we manipulate impulse and momentum in order to find out how much force being inflicted towards a system itself. So it can be both way. Boleh pergi ke depan, boleh pergi ke belakang. When we talk about impulse and momentum. Ni cara untuk kita play around lah. Contoh lah based on impulse momentum theorem. Okay. Ada soalan sampai sini dulu? Any question? Any question from the floor? Ada soalan ke tak ada?
Tak ada.
Okay. Alright, so this one is the diagram of force lah. Okay. Okay, next one, center of gravity. Center of gravity ni konsep. Okay, when we talk about center of gravity or center of mass, it is the point around which the body weight is equally balanced, no matter how the body is positioned. In a kinetic perspective, location of center of mass determine the way in which the body respond to external forces. Okay. In sport performance. Bila kita cerita COG dalam sport performance. COG. Center of gravity. Human. Okay, apa maksud COG yang paling simple? It is actually a point. Okay. Where at this point, the weight of the system ni is equalized. Contohlah, kita ambil weight tu keluar, katalah 30 kg. Weight tu ke kiri pun 30 kg. Weight tu ke bawah pun 30 kg. Weight tu ke atas pun 30 kg. Regardless kamu berdiri, kamu baring, kamu terbalik. The center of mass is still a point where it will divide the weight equally, regardless of position. Cuma kalau kamu berdiri, it will be here. Kalau kamu baring, it bukanlah kat sini. If you lying down, the center of gravity will be outside of your body, underneath. Okay, kalau kamu terbalik pula, dekat bahagian mana kamu rasa berat paling banyak? It will fall down a bit. Compare ni tadi kat pusat, so dia jatuh mendekati dada. So this COG, it keep on changing. Okay, it keep on changing. Places is changing. But there are always one COG. Okay, katalah kita nak buat 100 meter sprint start. Okay, dah ada kat starting block. At this point, the COG is not here anymore. No. It is actually there. In the front of you. And why it is in the front of you is because you are going to put your weight out of your body. Reason is one. Korang mesti pernah tengok benda ni. Speed, accuracy trade-off. Okay, most of you have seen this one. You try to have speed, the accuracy is less. You try to have accuracy, the speed is less. Okay, so in the case of this one, it is not speed accuracy trade-off, but it is actually stability versus agility trade-off. If you try to be stable, you are not going to be agile. If you try to be agile, you are not going to be stable. Example, main kejar-kejar. Okay, where you try to run left and right and change direction in instant. Okay, some of you when you change direction, you are going to fall down. Tengah-tengah lari ke depan ni kan, okay, you are running, mana saya punya pen? You are running forward, baik lagi laju ke depan macam ni. Okay, when you're running forward, you're going to feel that the COG is quite a bit behind. Okay, suddenly, in a sudden, you try to change your running position to the right. So, when you reach here, what happened is, your COG, okay, at this point, this COG is going to shift place because most of the weight now is forward, and when you change direction, instant to one side, this COG will also change places. Okay, apa yang menyebabkan jatuh? COG ni when it falls out of your, okay, out of there. Ni, out of this. Okay, out of this area. When the COG, macam ni kan? When the COG being put out of that area, you are prone to fall because you are not stable. But when the COG is not within the area, you are agile. If you try to be agile, put the COG outside of that area. If you want to have a stable condition, put the COG within that area. This area is known as with the name of base of support. Okay, ni nama dia, base of support. Apa itu base of support? Okay, base of support is the area, okay, the outermost area which encompass your body point that touch the ground. Okay, katalah kita berdiri. So, these are your kaki. So, area that encompass your kaki, this is known as base of support. So, as long as this COG being put within this area, tak kisahlah kat mana-mana pun, you are stable. Jadi, orang bersilat macam mana dia nak besarkan base of support? Dia besarkan dia punya kuda-kuda. So, the area become larger. Selagi COG dia ada dekat dalam ni, you are stable. Okay. Orang tua nak berjalan tak kuat. Apa yang dia buat? Okay, tapak kaki. Dia pakai tongkat. So, these are the new base of area. This is the new one. Compare to the original one kalau dia tak pakai tongkat. Jadi, COG dia lebih banyak boleh bergerak before falling down. Kanak-kanak yang tak boleh berdiri, what they are going to do? Okay, tapak kaki. And then we have lutut. And then we have tangan. So, these are the base of support. So, if the area of the base of support is larger, you are going to be more stable. Ni konsep yang kita boleh guna dalam sukan. Okay, base of support and the COG. The placement of the COG, make sure it is within the base of support. Or, katalah macam kita main rugby. Okay, we know that somebody is running towards you and try to collide with you, berlanggar dengan kamu, try to make you fall down. Okay, how we want to increase our stability? The first concept is that you know is place your COG within the base of support. Place that one. Okay, katalah this COG being located 10 cm from the edge. Maksudnya kalau dia keluar 10 cm, dia tak stable. In order to move 1 cm, you need 1 Newton. Okay, katakan. So, to move 10 Newton, to move 10 cm, you need 10 Newton. Okay, so how we want to increase that? Alright, like this. we know that orang tu datang pada sini nak tackle kamu daripada sebelah kiri. So what are you going to do is you are going to lean your body towards the force that come, so that COG ni tadi it will be shifted to here. Now untuk hilangkan kestabilan kamu, kita ada 10 cm and then we have another 10 cm. Total up 20 cm. So instead of just 10 Newton, this fella need to inflict at least 20 Newton in order to move this COG towards the other edge before it falls out of the base of support and you are going to lose stability. Ni konsep dia, how we play around with center of gravity in order to keep on your body stable and make you able to function properly. Ni yang pertama, positioning of base of support. Okay, itu adalah konsep dekat dalam center of gravity. Ni. Okay. Next concept is about weight. Yang ni kita dah bincangkan. Okay, kita dah bincangkan tadi. Weight is a force, mass is not, and weight is actually derivation of mass times with the gravity. Ni dia. Okay, mass time dengan acceleration gravity, and it will be reported in term of Newton. Ni contoh. If a scale show that an individual has a mass of 68 kg, what is the weight? So 68 times dengan apa ni? Kita timeskan dengan acceleration. So you're going to end up dengan berapa dia punya Newton. Okay, berapa Newton dia. Okay, alright. So we are going to take a bit of break and we are going to continue back at 11 with pressure. Okay. Dengan subtopic seterusnya which is regarding pressure. Right, so the definition of pressure we can write it out as small caps P is defined as a force divided by a given area. Tekanan ataupun amount of tenaga yang diberikan kepada sesuatu kawasan. So if the kawasan is large, the pressure is less. If the kawasan is small, the pressure is going to be more. Okay. Kita ada. Right. This is an example of a pressure. Soalan dia, is it better to be stepped on by a woman wearing a spiked heel or a woman wearing a smooth sole court shoe? If a woman weight, by weight, Newton. Kalau tulis mass, kg, and the face area of the spike is both 4 cm square and the court shoe is 175. So, if we take a look at this question, the first impression is that baik kena pijak dengan benda kecil ni daripada kena pijak dengan benda besar kan. Now we try to use pressure. Okay, so let's see this one. This first example. Mana yang lagi tinggi pressure dia? Okay. So let's calculate that one. The woman weight of the woman is 556 Newton. And the first shoe this woman wear is heel with an area of 4 cm square, while court shoe, the area is 175 cm square. Area ni lah. Kalau kata heel tu kan, kalau kita tengok bawah tapak dia kan selalu heel macam ni. Okay, and then court shoe is a shoe lah, normal shoe. So this area, okay, this area, these are the surface area. Okay, so the area for court shoe is 175 cm square, and the area, both of this area for heel, okay, noted to be 4 cm square. So now let's find out pressure for heel and pressure for court shoe. So pressure equals to force over area. Pressure equals to force over area. So we have pressure heel. Sorry, this one is small caps. Okay, equals to force 556 over 4, and pressure court shoe 556 over 175. Okay, 556 over 4. You end up 139 Newton per centimeter square. And for court shoe, we have, oh, sorry. We have 556 over 175, 3.18 Newton per centimeter square. Nak kena pijak dengan kasut sukan ke nak kena pijak dengan heel? So you choose by your own. So these are some use of pressure. Kita tengok contoh lain Okay, ni pressure dia. Siapa yang rasa nak kena pijak dengan heel tu silakan. The pressure is 139 Newton per centimeter square of area. While for the court shoe is 3.18. Comparison dia berapa banyak tu comparison dia 43 kali ganda. Okay, kena pijak dengan court shoe adalah 43 kali ganda lebih ringan rasanya berbanding kena pijak dengan heel. So for those who bring your girlfriend or whatsoever, make sure they are not using heel since it is actually part of a weapon to kill you. Okay. Contoh lain, let's see some other example of pressure. Yes, saya cari contoh pressure. Okay, this one. Alright. Let's see this example. Kita, mana saya punya pen? Okay. Kita ada satu gymnast. Okay. Let's say first we talk about gymnast flooring. Ni. Macam yang ada dalam lab tu. Benda-benda warna hitam. Okay. Let's say this gymnast mat. Okay. The weight of this gymnast mat is 220 Newton. Where it has a dimension. Okay. Dia punya luas dia ialah 3 meter times 4 meter times 0.04 meter. So the question is, how much pressure does this mat give to the floor? Setiap keping ni bagi berapa banyak tekanan kepada lantai? Silakan. Okay, so first we need to know the area. So in order to know the area, we have length, we have width, we have height. Jadi untuk tahu area, it is equal with length times width. 3 times 4. So you have 12 meter square. Okay, 12 meter square. Okay. So the pressure is equal with force over area where we have 220 Newton over 12 meter square. So the answer will be 12. 18.33 Newton per meter square, ataupun we can have it in term of Pascal. PA ni. PA is tekanan ataupun nama penuh dia Pascal. Ni untuk kita kira tekanan. Sekejap, cari lagi dia tak tekanan ni. Tekanan. 37% super berat body weight. Okay. Alright. Another example. Let's say kita ada orang. Okay, kita ada orang. So, alright. Kita nak ambil satu bahagian ni. Kita ambil bahagian vertebra ni. L5. Okay, vertebra L5. Okay, let's see 37% of this person weight, okay, being distributed over L5. Okay, where the L5 area is 25 centimeter square. That is the area. Okay, that is the area. And then the total body weight of this fella is 930 Newton. The question is, how much force being distributed here at the superior of the L5. Berapa banyak force yang kita perlukan? Okay, the difference between this one and before, we have pressure equals to F over E. Okay, the difference between this and before, the other question, is the presence of percentage. Tu je satu perbezaan dia. So, soalan dia, kalau orang ni 930 Newton and 37 of this is being distributed over L5, so how much force being exerted by L5? First, we need to know how much force being exerted dulu. So, in order to know how much force, dia dah bagi tahu dah 37%. So, force here is equals to 930 kalikan dengan 30%. 0.3. Apa kita dapat yang itu dulu? 930 times 0.3, we have 279 Newton. Okay. Ini apa? 0.37. Oh, 37. Sorry. Yang tadi 0.3 je saya kira. So 930 times 0.37. Right. So 344.1. That is the amount of force or weight being exerted by L5. Now, kita nak tahu berapa pressure dia. So, pressure equals to 344.1 Newton over the area of the L5 itself, 25 centimeter. So, we have 13.76 Newton per centimeter square. This is the amount of force every centimeter square exerted by the L5. Okay. Ini cara kita gunalah pressure ni. Apa lagi? Kita ada nucleus pulpus. Berat no. Alright. Ini pressure. Okay, tekanan. Okay. Kita kira satu lagi. Alright. Let's say we have different type of shoe. Satu, kita pakai court shoe. Okay, so lebih kurang macam ni lah kot tapak dia. Sini, no ni. Kita tengok tapak dia je. Okay, tapak. Dia ada something like that. Okay, another one, kita pakai kasut untuk trail tu. So, selalu kasut untuk trail dia ada arch yang lebih mendalam. Okay. Okay, let's say this is you. And you are 800 Newton in term of weight. Okay, this one, the area for court shoe is 160 centimeter square, and the area for trail is 115 centimeter square. This is trail. This is court. Okay. So, how much force being exerted by each leg? Okay. If we assume that our weight being distributed equally, okay, if we assume our weight being distributed equally, how much force, how much pressure being executed by the leg if you are wearing court shoe compare if you are wearing trail shoe? Tu contoh soalan dia lah. Okay, kalau kata kita assume, this is just an assumption. Our weight being distributed equally means that every part, every half of our body will exerted 400 Newton of force. Okay, now let's find out the pressure if we use what we call it. If we use the court shoe compare if we use a trail shoe. So we have 400 over 160, and this one is 400 over 115. So for the court shoe, we have 0.25 Newton per centimeter square at each leg, and for the trail shoe, we have 3.48 3.5 lah, 3.5 Newton per centimeter square. Sekejap rasa macam tertinggal nombor ni. 160. Kan betul. Saya tertinggal 1 kosong. 2.5. Okay. So if you are wearing court shoe, it inflicted only 2.5 Newton per centimeter square of the area. But if you wear trail shoe, it will inflicted a Newton centimeter more. This one is the pressure being inflicted to the ground. Okay. So based on Newton's third law, whatever you give, you get back. So that whatever action that you do, there will be a reaction force, but in different direction. So the answer will be similar. If the question will be what is the best shoe in order to reduce strain towards the muscles, toward the body, it will be the less pressure shoe. Jadi kamu akan lambat rasa letih because less pressure being inflicted to the leg of yours. Ni untuk penggunaan pressure. So please take note, and this is actually some of the thing that you need to have in your presentation. Okay, next one is regarding volume. Okay, isi padu. Body volume is the amount of space that is occupied by the space within the width, height and depth. Tadi kita ada length and width saja, kita tak ada depth. So bila kita increasekan depth, include depth, dia akan jadi isi padu. Okay, ni benda ni. Jadi kan kita ada ni. Ni. So if we try to find out luas is this one. Tapi kalau depth, we need to include this. So what is the volume for each of this mat? So it will be length, width, depth. It will be 3 times 4 times 0.04. Apa kita dapat ni? 12 kali 0.04. So isi padu dia ialah 0.48. This one is meter. Meter 3, right? That is isi padu. Ataupun dalam bahasa Inggeris dia, it will be volume. Okay, it will be volume. Sekejap. Okay. Next one, we have density, ketumpatan. Ni P ni. P ni nama dia rho. R-H-O. Okay. Kadang-kadang kamu akan jumpa P yang lebih ekstrim daripada P itu. Ni. This is rho. Ketumpatan. Kadang-kadang kamu jumpa macam mana bentuk dia paling. Ada yang macam pun rho. When you see density, this is not P anymore. This is rho. Okay? The way to pronounce it is rho. This is P, pressure. But P for density being known as the name of rho. Okay, so apa itu rho? Rho is mass bahagi dengan volume. So if you has more mass or you has same mass but different volume, the density will be differ. Okay, so kita tengok contoh density. Macam mana kita nak guna density? Okay, sekejap. Gymnastic floor, volume. Okay, this one. Okay, this is some example of density. Okay, so I write it back. Density. Okay. P ataupun this is rho equals to mass over volume, where volume equals to height, length, depth. So kalau kita ada tiga benda macam ni, sorry saya lukis. We have something like this. So this will be dia punya depth. This will be dia punya length. This will be dia punya width. Ataupun pakai width terus. Length, width. Okay, tu dia. So that is volume. Alright, so let's take a look at an example. Okay, kita ada 3 kotak. Okay, what is the volume of a milk crate with side of 25, 40 and 30? Okay, kita ada 25, 40 and 30. Means that kotak consists of something like this. 25 centimeter, 40 centimeter and 30 centimeter. So what is the volume? So V equals to 25 times 40 times 30. So we have 30,000 cubic. Okay, centimeter cubic. Ni nombor 3, nama dia centimeter cubic. Okay. So kalau okay, kalau 1000 centimeter cubic sama dengan 1 liter. So 30,000 centimeter cubic will be equals to 30 liter. Ni isi padu. It can be in centimeter, it can be in cubic, it can be in liter. Okay. Now the derivation of question. Based on whatever you have from before, so the box we have calculated and we find out that the volume of this box is 30 liter ataupun 30,000 centimeter cubic. Okay, if the content of the crate, katalah barang kat dalam kotak ni, we have something in this box. Okay, if the content of the crate weight at 120 Newton. Okay, if the content of this box is 120 Newton, what is the density of this box? Berapa dia punya rho? Equals to mass bahagi dengan volume. Berapa dia punya density? So I'm going to give you 5 minutes and please find out the answer and post the answer in the chat. Kita apa? kg per centimeter square. So kalau kita jom kita tengok kalau kita convert dia ke beberapa nilai. Okay, so we have mass 120 Newton. This one need to be changed to kg first to what we call it, to weight. We need to change this weight to mass dulu. So it will be 120 divided with 9.81. Kosong point berapa ni? 120 bagi 9.81. So saya dapat 0.122. Okay, ataupun it will be 12.2 kg. Okay. Right. This is the mass. 12.2 kg. Okay. So we have the mass. Now the volume is 30,000 centimeter square. Okay. Katalah kita tukar yang pertama kg kepada meter. So 30,000 centimeter square bahagi dengan 1,000, kita dapat berapa? 3,000. Okay. 30,000 divided by 1,000, we have the 30 meter square. 1 meter is 100. Sorry. That will be 300. Ataupun 300 meter cubic. Okay. So kalau 12.2, okay, in term of kg and meter, so we have pressure equals to 12.2 over 300. 0.041 kilogram per meter kubik. Okay. Lagi dalam unit apa lagi tadi kamu bagi? What are the other unit? 0.041 kg yang bawah ni, equal ni, kg per meter kubik ni. Nur Akilah, yes. 4 kg per meter. Okay, terlebih ni, terlebih. So, please find out 0.04 kamu kurang 10. Ialah 0.04 kg per meter cubic. That will be the answer lah. Alright, this one is about pressure. Kita tengok ada lagi tak pressure lain. Fluid flow, ligament, muscle, pressure. Pressure, this. Weight, man. Okay, this one we have done that. 25 done. This one is done. This one is done. Okay, so we move on to our next properties. Selepas pressure, density, volume, we have torque. Okay, torque ni ialah force. This is also force. Okay, but what is the difference? Okay, when we talk about torque, okay, T-O-R-Q-U-E ni, Q-U-E, it is actually angular force. Okay, so kalau kita ada satu benda, we have an object like this, we inflict force, it will cause this object to move. This movement is known as linear motion ataupun translation. Okay, but when we have a force, when we have an object and this object has an axis of rotation, kita tahu dia takkan bergerak ke depan dah. Axis of rotation. Okay, if we inflict force in the same line of the axis of rotation, nothing is going to happen. But if we inflict force here, if we inflict force there, okay, this is a torque. So we inflict force here, we are going to see rotational movement. This rotational movement is known as angular motion ataupun rotation. And a force which produce a rotation known as torque. Tapi bila kita tengok torque, T ni, it is a derivation of force kali dengan distance. Okay, this is known as distance. Ataupun, it is also known as radius. Okay, so apa dia? Right, this is what the distance talks about. Okay, kita ada object. This object rotates because it was inflicted with a force. So the distance is actually, ni distance dia. Bila kita nampak satu force macam ni, we need to draw a straight line and then we need to draw another straight line in the same direction as the force being applied, but this line need to be intersect with the axis of rotation. So the distance between this line and the line of force, ini dia punya D ataupun dia punya radius. Okay, next. We have an object. We have an object and we inflicted force like this. It will cause the object to rotate for sure. Jadi mana dia punya diameter, dia punya distance. Okay, line of force, another line crossing the axis of rotation. So the line, the distance between these two is distance. Kita ada force. Okay, kita ada force and we applied force. Kita ada force. Kita ada object, we applied force here. So we need to draw a line straight from the force and another line intersect with the axis of rotation, the distance between these two is the distance ataupun dia punya radius. Ni dia punya ni bahagian ni. Sorry, FD pula. T equals to FD. Torque equals to force and distance. Ni distance dia. These are how you want to find out the distance. Okay. And then when we talk about force, it always involve multi-directional force inflicted in different direction. Maksudnya kalau force macam ni, bila kita apply force here, there are reaction force another way. Okay, there will be another force acted perpendicular and that cause rotation. Same as human body part. Human body part works by using torque. We take a simple example of our own hand. Okay, this is our hand. This is our radial ulna. This is our humerus. This is our shoulder. SHOU, the shoulder. So we know that our hand column, our hand segment can contract and can elongate, retract. Okay, contraction, extension, contract, extend. Our elbow. So this elbow will serve as your axis of rotation. Okay, macam mana tangan ini bergerak? By having your bicep and your tricep. Okay, kita ambil satu je, bicep. This bicep being attached to your forearm somewhere around there. Sini ada distance lah. There are a bit of distance. So this bicep produce force. Force of contraction ke atas. At the same time, when we have beban or we don't have beban, there are another force pulling your hand downwards. Force juga. Force of gravity atau force of beban atau force of resistance. So if we take a look here, satu force naik ke atas, satu force turun ke bawah. So multiple force acted in different direction. This cause torque. Torque at where? Ni, dekat siku. Pergerakan dekat siku. This is known as torque because it involves two different direction of force acted upon the system. So F dia yang mana? This will be the F. D dia yang mana? This will be the D. The distance between the insertion of your bicep to the axis of rotation. Ni lah. So this is your bicep. This is your elbow. So these are the D. The end or the insertion of your bicep to the axis of rotation is the distance, which is the distance that we are trying to find. Itulah dia. Itu torque. Okay, this is a concept lah. Okay, so when a force is applied to an object, either translation or general motion may result. If the applied force is directed parallel to the desktop and through the center of the object will be translated tegak. Tapi kalau the applied force is parallel to the desktop but directed through a point other than the center of the object. Okay, dia ada dua tu kan. Centric force dengan eccentric force. Okay. This is known as centric force. Macam tadi, kita ada object. This is the center and we applied force. This is known as centric force. It causes a translation. Translation adalah pergerakan daripada point A ke point B in straight line. Okay. Another type of force is being applied parallel to the center. This is known as eccentric force. So it will cause satu, rotation. Dua, translation. Means it will cause the object to move forward at the same time rotate. This is known as angular. This is known as torque. This is known as linear. Dia tak ada apa-apa rotation pun. It cause a straight motion forward. And this is called as force. Tu dia, beza force and torque. Both is force, but one is known as centric, another one is known as eccentric. One cause only translation, another one cause both translation and rotation. Okay. Tu dia. And that is torque. Okay, the difference between torque and force. So in human motion, most of our action is caused by torque. Pasal kita memang melibatkan body joint. We cannot move forward, backward, or whatever thing that we try to move. We cannot somehow we cannot propose those movement if we are not moving through our joint. And when we move through our joint means that that is the axis of rotation. So the movement is a torque. Not just a linear movement. Okay, ni contoh lah. Okay, centric. Ni centric. Bila kita tolak, hasil dia either translation. Tapi, when we apply a force towards parallel, okay, parallel to the center of mass, it will cause, kita panggil macam rotation lah, but it is cause a rotation and also a translation. Ni translation, bergerak ke hadapan. Ni bergerak pada point A, point B, translation. And the shape of the translation is actually a rotation. Why it happen like that? Because torque being produced, a force being proposed to the object parallel to the center, causing it to translate and rotate. So eccentric force is a torque. Okay, centric force is a, what we call it, a force. Okay, yang ni impulse kita dah bincang tadi, impulse and momentum, it is interrelated with one another with impulse momentum theorem. So please remember that one. Penggunaan ni macam yang tadi tu. Okay. Alright. So next we have vector algebra. Before we go to vector algebra, we need to be able to differentiate two things. Okay. Satu nama dia skala unit. Satu nama dia vektor. Okay. Both of these has magnitude. Okay. Apa itu magnitude? That is the first one. Magnitude. Kita ada satu bola. Kita sepak. Okay. 30 Newton. This is magnitude. Berapa kuat? Berapa kuat? How much force inflicted? 100 Newton. That is the magnitude. 200 Newton, 2000 Newton, 8 Newton. How much being answered by magnitude. Number 2. Dia ni tak ada. Vector has direction. Okay, macam mana tu direction? Macam ni. Okay, contoh. Kita ada bola. Kita sepak bola. Bola bergerak. V equals to 2 meter sesaat. Sometimes you see something like this. Dia bergerak ke sana. Okay. Different direction. Causing yang ini ialah V equals to negative 4 meter per second. Ni. Longer the arrow, the higher the magnitude. The difference direction of the arrow showing whether it is a positive or negative. So what is the difference between positive and negative in term of magnitude? Tak ada. Kalau ni 2, ni 4, ni lagi banyak lah magnitude. Tapi adakah negatif 4? Negatif 4 sama banyak ataupun berlainan dengan positif 4 in term of magnitude? No. The magnitude still 4. The difference is just negative, means it's moved that way. Positive, it move to the right. Dia ada direction. When we talk about vector, it has direction. When we talk about direction, please remember this. Cartesian coordinate. Kita dah belajar benda ni masa topik kedua. So anything that move from left to right, the figures will be positive. Anything that move from right to left, the figures usually be negative. Same goes as the object move bottom up, positive, and from top to bottom, negative. Ni paksi Y, ini paksi X. When we talk about X, is more towards direction left and right, and this is more towards the velocity. But when we talk about Y, it is more towards up and bottom, and it is more towards acceleration. So positive acceleration means increase of velocity. Negative acceleration means decrease of velocity. Ini maksud direction in vector. Okay. So vector algebra, okay, vector is a quantity that has both magnitude and direction represented by arrow-shaped symbol. Force, weight, pressure, torque, all those quantity can be described in vector algebra. Okay. Okay. So scalar unit, however, possess magnitude but does not have particular direction such as mass, volume, length and speed. Kita tak ada negatif 80 kg. Tak ada. Okay, tak ada. Tapi negatif 80 meter per second ada. Means it move to the left ataupun it is undergoing a deceleration cases. Okay. So distance and speed that can be completely described in terms of size, magnitude are known as scalar quantity. Displacement, velocity and acceleration that require specification of both direction and magnitude are called vector. So to visualize vector quantity, we use arrow to represent those vector because it has both magnitude and direction. Okay. Dia akan pakai arrow. And when we talk about arrow, there are vector composition. Okay, vector begini. Kalau kita nak cerita force. Okay. Katalah 1 Newton of force equals to 1 cm of length. Jadi kita ada benda macam ni. This is 1 Newton. So kalau kita ada force yang macam ni, means that if we name this is force A, this is force B. So force B is larger than A. Why? Because it is much more lengthy. Dia kena ukur sebenarnya. Ini vektor. So kalau vektor tu macam ni, means the force being applied upwards. Kalau vektor tu macam ni, the force being applied downward. So kalau yang ini force dia 10 Newton, yang ini negatif. Tahulah negatif 20 ke. This is just to show the direction to force. And then, when we have vector algebra macam ni, kita ada vector composition, penambahan vektor. Okay, where in vector composition, there are multiple shape. The first one, same direction. Okay, tambah 1. Kalau yang ini 1 cm, yang ini 3 cm. So hasil dia ialah satu anak panah yang mempunyai panjang 4 cm. This is vector composition within the same direction. 1 cm ke atas, 1 cm ke atas, tambah. So kita ada 2 cm ke atas. 1, 1, 2. This is vector composition. The first shape. Okay. The operation when vector are added together. The composition of two or more vector that have exactly the same direction result in one single vector that has magnitude. Dia contoh dia. Okay. Untuk yang pertama ni, ditambah. And then, it is the same direction. So, you just add on the length. Okay. Jika arah dia adalah sama. Okay. And then, number 2, resultant vector. Single vector result from a composition of two or more vector. Two vector oriented in exactly opposite direction are composed. Resultant has the direction of the longer vector and magnitude. Ini bila arah dia tak sama. Okay. Composition of vector when the direction is not equal. Kalau equal, kita tambah length dia. Okay, kalau tak equal, contoh, kita ada satu ke kanan, setelah ni 2 cm, dan satu ke kiri, 1 cm. So, hasil dia, tengok yang mana yang lagi panjang. 2 lagi panjang. So, we know that the hasil will be to the right. Berapa panjang? The difference. If we take this into mathematical equation, it will be something like this. Ni kan ke kanan, so dia ialah plus 2. Tambah. Ini adalah ke kiri. Dia ialah negatif 1. Tu kalau kita jadikan the mathematical equation. So it will be 2 tolak 1. Jawapan dia ialah 1. 1 apa? Positif. So the direction of arrow need to be to the right. The length of this arrow need to be 1 cm. Okay. Ini orientation yang sama. Orientation kena sama. Kalau dia kiri dan kanan, sama. Dia tak boleh satu ke atas, satu ke kanan. Kita tak boleh pakai composition. Okay, kita tak boleh pakai compose. Ini ada cara lain. Okay. Yang kedua, kalau di atas dan ke bawah. Satu naik atas, katalah 3 cm. Plus turun ke bawah, 5 cm. So, it will be, yang mana lagi panjang? Yang mana lagi banyak ke bawah. So, we know that it will be pointed downwards. How much? The difference between these two. 2 cm. In mathematical model, it will be plus 3 plus dengan minus 5. So, kamu akan dapat 3 tolak 5. The answer will be tolak 2. Sama. 2 cm in term of length downwards. That is vector composition. And you can use this method only when the plane is equal. Kalau dia horizontal plane, dua-dua kena horizontal. 2 ke 3 ke 10 ke, all of that is in horizontal plane. Kalau dia vertical plane, all need to be in vertical plane. It does not always mean kita buat 2 je. Kadang-kadang ada soalan macam ni. 1 tambah 1 tambah 1 tambah 1 lagi tambah 1 tambah 1. Okay, ni ada buat banyak Okay, katalah kita buat ni lah banyak dia. Okay. So, dia akan ke mana? Kita kena tengok panjang. Kita assume ni 1, ni 2, ni 4, ni 3, ni 1, ni 1. Okay. So, berapa panjang kita ada? Ke kanan 1, 3, 6. Ke kiri 4, 5, 6. Sama. So, kita akan dapat result? Nada. Tak ada. Okay. Confirmation. Okay, we do that in mathematical equation. Plus 1 plus 2 plus negative 4 plus positive 3 plus negative 1 plus negative 1. Okay, kita dapat apa? 1 tambah 2 tolak 4 tambah 3 tolak 1 tolak 1. 1 tambah 2, 3. Tolak 4 jadi negatif 1. Tambah 3 jadi 2. Tolak 1 jadi 1. Tolak 1 lagi kosong. So jawapannya kosong. Tak ada anak panah afterwards. It can be only happen if the plane is equal. Horizontal. Kita tak boleh tambah horizontal dengan vertical. Itu adalah untuk type kita yang ketiga. Okay. Also possible to add vector that are not oriented in the same direction, but you need to do tip to tail method. Procedure may be used which the tail of the second vector is placed on the tip of the first vector. The resultant is then drawn with its tail on the tail of the first one and the tip on the second one. Okay, dia macam ni. Bila mana vektor kamu is in different direction. Okay. So we have 1 plus 1. Okay. 2 direction. 1 vertical, 1 horizontal. Katalah ni 1 cm, ni 2 cm. So hasil dia. First, draw the first one. 1 cm. And then draw the second one. Starting from the tip of the first one. Ni tip dia kan? Okay. Naiklah ke atas. Sama dengan bentuk asal dia. 2 cm. So hasil dia is not this one. The resultant is the one that connect these two. Okay, nak connect macam mana? Sambungkan ekor yang pertama dengan kepala yang kedua. So direction dia ialah ke arah yang terakhir. These are the direction. So these are the resultant. In other words, if you place these two, jawapan dia adalah ini. How much is this one? Ukur lah. 1 cm, 2 cm, ukur tu berapa cm. Tu lah jawapan dia. Okay. Proof kan. Okay. To prove that, we are going to use Theorem Pythagoras, which is r square equals to a square plus b square. This is a, this is b, that is r. So R equals to A square plus B square square root of it. A berapa? 1. 1 kuasa 2. B berapa? 2. 2 kuasa 2. Punca kuasa. 1 kuasa 2, 1 lah. Okay, 2 kuasa 2, 4 lah. 4. Kuasa 2, kuasa 2. So, jawapan dia ialah 2. Means R, the length need to be 2 cm. Ni kalau vektor dia berlainan plane. Okay, another one. Let's say kita ada 1 plus 1 plus 1. Okay, 1 cm, 2 cm, 3 cm. Mula dengan yang pertama. So, kita akan ada 1 cm ke kiri. And then kita ada 2 cm ke atas. 2 cm ke atas. And then kita ada 3 cm diagonal. So, hasil dia daripada point tail yang pertama ke head yang terakhir, tip yang terakhir. Sambungkan. And then the anak panah need to be towards the last tip. So, these are the vector. The resultant vector. Ni cara dia. Bolehlah tambah sampai berapa banyak pun. Okay? Bolehlah tambah sampai banyak pun. Ni kita panggil sebagai tail to tip. So, kalau kita ada lagi sekali saya tunjuk. Okay, kita ada 1 plus 2 plus 3 plus 4. Okay, ni 2 cm, 3 cm, 2 cm, 2 cm. So, hasil dia macam mana? Ukur daripada yang pertama. Okay, 1. Yang kedua, kita akan mulakan dia pada kepala yang pertama. Okay, in the same direction. 2. Yang ketiga, mulakan dekat kepala yang kedua. 3. Dan yang keempat, akhir sekali. Okay, so direction akhir dia itu. And the resultant is daripada ekor yang pertama hingga kepala yang terakhir. Just have a straight line connecting these two. And you put your arrow pointing at the same direction as the last one. So, these are the resultant. 1, 2, 3, 4. Resultant. So, measure the length of the resultant. That will be your answer. These are vector composition. Okay, and the later one is known as tip to tail method. Tu dia. Cara untuk kita tambah. So, that yang kita tambah last tu lah dia punya resultant. Okay, itulah jawapan dia. Composition dia. Okay. Sampai situ dulu. Ada soalan? Kita dah sampai kepada type force. This is towards the last part lah. Any question before we proceed to the last one? Tak ada.
Tak ada rasa.
So the last one is regarding type of force. Okay. Kita ada compressive, kita ada tensile, kita ada shear. Boleh ke dia? So the first one is compressive. Compress. Push. Okay. Compression is push. This one. We push towards one another. Pressing or squeezing is known as compression. Compression. Okay. Yang kedua is tensile. Pull. Tadi kan kita ada force. Push and pull. So, push is also known as compression. Compressive. Tensile or tension. Dengar tension. Tension. Tension is actually a pulling force. Okay. Which create tension between one another. Dia tarik. And the third one is known as shear. X parallel or tangent to a surface, it tend to cause one portion of the object to slide, displace. Okay, shear ni, tu dia. When we give force from different direction. Okay, to the tangent. Maksudnya tegak. Okay, maksudnya tegak. Kalau atas bawah kita bagi, that is compression. Okay, ini objek kita bagi dia daripada tangent, daripada parallel. Kiri dan kanan. It cause it to split into half. This is known as shear force. Ini selalu force-force yang ada lah selain daripada blow semua tu. Okay. And then, we have a combination. This is what we call dia punya primary shape. Compression, tension, or shear. And then, we have combination. More complicated type of loading is called bending. Lepas tu kita ada torsion. Okay, so bending, when we have both compression and tension. Okay, pure compression and tension are both axial force. They are directed along when an eccentric force. Okay, lagi satu kita nak faham yang tadi. When we try to have an idea about compression, tension, and shear, this one is centric. Okay, this one is centric. Complicated type is more towards eccentric. Maksudnya dia tak selari dengan objek itu. Okay, so we have bending, we have torsion. Ini yang paling major. So bending is an eccentric type of force, okay, ataupun asymmetric loading, produce tension on one side of a body longitudinal axis and compression on the other side. Contoh macam ni, we put compression towards the middle, it cause bend. Jadi bahagian ujung tu sebenarnya dia jadi semakin panjang. That is pulling action, itu tension. So bending is a combination of both compression or compressive force and tensile. It cause both compression and tension at the same object. Okay. Yang kedua ialah torsion. Tadi kita ada shear, where shear we actually put force from here and from bottom up. But torsion is some sort of shear, but it caused by twisting action. Shear tadi kita tolak satu atas satu ke bawah. That is shear. Now, we put compression and torsion. Compression and twisting. It is known as torsion. Okay, so selalunya torsion ni, kalau macam tadi kita ada shear, it breaks in the middle. Torsion ni, it shattered. Okay, dia akan hancurkan bahagian tengah tu. Because both of the rotation is in different direction. One rotate to the left, one rotate to the right. Same as shear, but shear is just a linear force. Torsion is an angular force ataupun torque. Okay, so torsion is caused by two torques. Okay, dua. Torque caused by two force linearly, satu atas satu bawah, cause rotation. Now bahagian depan kita tolak macam ini, satu atas satu bawah. Okay, macam ni saya konsepkan dia. Okay, this one is shear. Kita nak keluar. This one is shear. We give one linear force here, force 1, we give one force here, force 2. Linear. Torsion is we rotate. Maksudnya kita bagi torque 1 dan torque 2. We know that in order to make a torque, kita kena ada force from two direction. Force 1, force 2, cause it to rotate. Now, this rotation, we give it twice. One to the right, one to the left. It cause a spiral fracture towards the system axially. Axial ni ikut dia punya angle lah, ni torsion. So torsion ni adalah antara form of force yang complicated. Okay, contoh macam ni, kita ada tulang, ni human bone. So this one is compression. Our bone is very good in order to dissipate compression. This one is tension. When we pull the bone, this one is shear. Okay, this one is shear. You are going to get quite a distinct fracture. But when we give torsion, it will shatter. Okay, our bone is not programmed to face torsion force. Dia diprogramkan untuk compression force. And then finally we have combination both torsion and compression. Okay, torsion and bending. This is the most complicated type of force lah. Okay, so tools for quantification, yang ni untuk pengetahuan saja. Some of the tools we have here. This one is EMG, in order for us to determine muscular contraction, muscular activity. So EMG can give you 3 different type of data, main data. One is the intensity of the contraction. Number 2 is the duration of the contraction, and number 3 is the sequence of the contraction, which muscle contract first, which contract last. Okay, to EMG. Other than that, we have dynamography and also force split. All of that uh, is the tools that we use in order to determine force. Ni contoh force split lah dekat bawah ni. Jadi dia nak tahu berapa banyak force being delivered to the leg. Okay, it record how much force being delivered to the leg. So we quantify that in term of GRF lah, ground reaction force, and in term of Newton third law. So how much being exerted, that is the amount of force being generated back to the leg itself. Okay, so that's all for our kinetic topics. Okay, so based on what we have learned and discussed, you need to have all of that in your presentation. But tak perlulah every single movement tu kamu analyse semua. No, you don't need to do that. You just need, okay, part ni saya nak cerita tentang force. Part ni saya nak cerita tentang tentang vector. Part ni saya nak cerita tentang pressure. Part ni saya nak cerita tentang acceleration. Part bola ni saya nak cerita tentang displacement, momentum and impulse. So you just need to show that once in your presentation. Okay, you need to show that you're able to grasp the idea what is biomechanics, how we do some simple biomechanic analysis towards patient, and towards the last part tu, you based on impulse momentum theorem, based on what other thing that you know, summation of force, you need to have you need to actually come up with some ways. Okay, you need to come up with means in order to enhance the performance of your athletes. Kalau dia ni sepak macam ni, kita nak jadikan dia lagi kuat daripada ni. That is the end of your presentation. Okay, that will be the end of your group assessment. Macam mana. So, kamu kena tunjuk apa yang terjadi, and kamu kena tunjuk macam mana kita boleh further enhance the outcome of the performance itself. So, that will be your group presentation, and it will be due on week 13. Okay, week 13 lah. Okay, so next week, saya akan tunjukkan kamu benda ni. So for this week, sekejap, kita tak dapat tengok. Okay, apa yang saya nak kamu buat, I need you to download this one and install it in your PC. Okay, after that, I need you to actually have sample of video. Salah dapat video sendiri ke, video apa ke, regarding a performance. Okay, can you see this one? Can you see this Kinovia?
Can, sir.
Can, sir.
Okay, video yang saya nak kamu cari ni, dia ada satu je kriteria. It can be from like this, from frontal plane. It can be from sagittal. Okay, either one. But I need you to have a video macam ni. Video, and the video plane is quite nice. Ni plane, nampak plane dia tak bergerak. Saya tak nak kamu ambil video yang macam sekejap angle sini, sekejap angle sana. The angle is keep on changing. If possible, just take a short video within the same angle, within the same plane. Because when we use Kinovia, first kali kita kena buat menatang ni. We need to do calibration. For example, macam ni lah. Okay. So, apa yang kita nak calibrate kan, we need to calibrate the length, because Kinovia is very sensitive to length. Jadi kamu kena ada satu video yang plane dia tak berubah. So, and then you know the length. Contoh macam tiang bola ni berapa tinggi dia? Example, somebody who play soccer, how high is this goal post? Berapa tinggi dia? Wih, tak ada orang main bola ke? Serious playing football. 1.8, 2 meter dia.
10 kaki, sir.
10 kaki 3 meter something. Okay, bila kamu dah buat tu, barulah ukuran-ukuran lain ni dia akan follow. Kalau tak, kamu punya ukuran nanti semua biol. Ukuran panjang biol, ukuran laju biol, angle will be biol, because it need calibration. And then to calibrate, it is advisable to use a very steady plane video. Jadi kita boleh tahu terus, okay, tu jarak dia tu 2 meter. Okay, so I need you to download this Kinovia. Dia ada banyak version, ambil lah version yang paling paling atas sekali. Okay, if I'm not mistaken, this one is 9.5, 0.9.5. Okay, download this one, just type je kinovia.com, tengok je yang paling atas, download that, and then find a video which has this kind of plane. Cuma plane kamu frontal ke sagittal ke apa, tak ada masalah. Okay, tak ada masalah. Okay, I need you to play around first. Cubalah main-main kat bawah ni. Skeleton ni buat apa, lepas tu line-line ni buat apa, marker buat apa, angle buat apa, how can we track performance kan. Contoh macam kita nak buat tracking, kita nak buat tracking, like example, let's make this one first to try. Okay, tracking path, start tracking. Dia tak ikut. Kita ambil bola jap. Dia ni sensitif dekat warna sebenarnya. So kalau dia detect warna benda tu tak berubah, dia tak jadi apa-apa. Dia stay je dekat situ. King start tracking. Can it track? Nampak?